Hi folks, I want to talk to you today about unit conversions. We have talked about unit conversions, but still I think we need to review some of this stuff. Let me just kind of begin by addressing how we do a problem using the up-down method of unit conversions. And I have tried to simplify it into 4 steps. The first one being read the problem all the way through. Seems like a no-brainer, but sometimes we begin writing down numbers before we even know where we're headed. The second step is to identify the given or starting place. What is the information that we're given that we know, from which we then have to find an answer through the use of a formula or unit conversions? So we're going to identify the given or the starting place. Generally, we start conversion problems by putting that over 1. As we get more involved, you'll see that it may already be over another unit, and our problem is a little bit more convoluted. Number 3 is to identify the ending place. And that is the units in which our answer will be given. And finally, it's figure out what the other numbers given in the problem are for. It's like we have to, given in the problem, are for. Are they unit conversion factors? Are they part of a formula? Are they red herrings? In other words, you may not need them at all. That's why you really need to be able to think when you're doing these problems. So those are the 4 steps that I want to continue to go over in our approach to solving unit conversion problems through the up-down method. Read the problem all the way through, identify the starting place, the given or the starting place, identify the ending place, the units, and figure out what the other numbers given in the problem are for. Are they unit conversion factors? Are they part of a formula? Do we not need them at all? Keep in mind that our unit conversion factors are not always given simply as a fraction, but maybe written in words as a this per that, pounds per square inch, something along those lines. Be on the lookout for how to identify those. We're going to just take a look at some problems. And this first problem is one that we worked with yesterday just in class. So if the average person weighs 135 pounds, how many people are in the elevator carrying a total of 1,215 pounds? Yay! I just did step number 1. I read the problem all the way through. Step number 2 is, what is my starting place? What is my given? Well, I'm given that the elevator carries a total of 1,215 pounds. That is my starting place, and I'm just going to write that down. And I'm going to put it, and I'm going to add the units, and I'm going to put it over 1. Now, I'm going to identify what my ending place needs to be. And I read the problem, if the average person weighs 135 pounds, how many people are in the elevator? So my answer needs to be in how many people. People is my unit. And then number 3, what are the tools? Actually, this is number 4. What are the tools I have available? The average person weighs 135 pounds. The average person weighing 135 pounds can be viewed as a conversion factor. It is a this per that. Or rather, I'm learning that one person weighs 135 pounds. And so the conversion factor will have pounds on one side, on either the top or the bottom, with the person or people on the other. Because I have pounds in the numerator here, I'm going to put the 135 pounds on the bottom per person, which is singular for people, on the top. And then I'm going to take a look at the units. I have pounds in the numerator, I have pounds in the denominator, and they will cancel. The only unit I'm left with now is the unit of person, people, as if you look at it in plural form. And that's what I want, people. So now I just solved the problem, which becomes 1,215 divided by 135, which equals 4, with my units next to it. 4 persons. That's how we solve the problem using the up-down method. Looking at the second problem, and this is the one that we had a little grief with on the quiz, let's just go through the 4 steps. If a nickel atom has a mass of 9.746 times 10 to the negative 23 grams, how many atoms of nickel would be present in a cube of nickel having a total mass of 17.8 grams? Step 1, I read it all the way through. Yay! Step 2, I need to identify the starting place. What is my given? 17.8 grams is my given. That's what I have. Other stuff are numbers that tell me about things, but I have a cube of nickel with a total mass of 17.8 grams. Step 3, what is my ending point? What am I looking for? Well, I'm looking for atoms of nickel. So the units in my answer will be atoms. And then what is the other information in the problem? What are the other numbers that I will use? And the other numbers that I will use, because there's a whole lot of them here, if a nickel atom has a mass of 9.746 times 10 to the negative 23 grams, that's the other information. So what I'm given is grams per nickel atom. And that is a conversion factor. It is a this per that. So in order to solve this problem, I start with my starting place, 17.8 grams over 1. And then I use this conversion factor. Here's grams and here's atoms. I'm going to put the grams in the denominator because I want to get rid of them. Here's grams in the numerator. I want grams in the denominator. So I will write 9.746 times 10 to the negative 23 grams here in the denominator. And that is per nickel atom. And then I take a look at my units to see where I am. Here are grams in the numerator, grams in the denominator. They cancel. Atom is left in the numerator. I want atoms. Then I'm done. I can solve this problem. And it becomes 17.8 divided by 9.746 times 10 to the negative 23. And the answer becomes 1.83 times 10 to the 23rd. And that's being conversant with the use of exponents. You subtract a negative, it becomes positive. And you should expect a huge number because we have a whole bunch of atoms in that cube of nickel. And I always ask myself, does this make sense at the end? And it does. So that is how you solve this problem using the up-down method of unit conversion.